Hello, everybody. Thank you all for coming. I want to apologize again for the safety inspection snafu we had today. And we really appreciate your patience in not fucking up the hotel. Security actually came by and said, hey, they didn't do anything for the last 2 hours. That was pretty cool. I said, the day's young. So just a couple of real quick warnings. Like I said earlier this morning, please do not hack the fire system. This is a hotel that would be very bad, because if there actually is a fire and people don't know about it, then people could die. That'd be very bad. So please, show some restraint.
All right, let's get this thing started here. Okay, so again, apologies for all the delays and everything. I think the only people actually making any money off this whole thing are the telephone companies trying to round up all the speakers. Okay, we are at least some of the Church of Wi-Fi. Basically, let's get this going here. Come on. Nope. Back up. Okay, if anybody has a good deal on a new laptop, I'd really like to hear it. This thing's crap. There we go. Okay. So the Church of Wi-Fi, just a quick background here. Oh, to my left, this is Thorn. Over here, we've got Hikari. Apparently you brought a cheering section. Okay. I'm Renderman. Okay. Church of Wi-Fi, basically we were founded by Blackwave, who is well known within the war driving community. Basically it was a joke site that started off and just kind of grew and became this whole thing. The idea was just a place that people could put their wireless projects so that they could collaborate, just get the information out there, because there's a lot of guys working on stuff in their basements that just never sees the light of day. And you know, there's really cool stuff out there. Why not give people a platform to get it out there? Anybody can join, so if you've got some project in the back of your mind that you want to get some help on, or just collaborate with other people who are similar interests, just hop on there and see what people are posting. We just want ideas. Ideas are cool. Ideas are what this whole community runs on. This is our currency. This is what we trade and share. This is really cool. We got lots of good ideas out there. Let's use them. Yeah, man. And I think I locked up. Yep. I really need a new laptop. Oh, she went down hard. Yeah, that was bad. Okay. Yes, but there's also Linux on there. You got to deal with the devil sometimes. He says at least it's not Vista. This thing would not run Vista, believe me. Oh yeah. So I'm going to try to remember what my slides were here, and we'll just go from that. Basically, what we're here today is just to show off some of the new stuff that we've developed since ShmooCon. We had a really good time there, showed off some new stuff. Bought some really nice shirts. Thank you, Bruce. And we just wanted to elaborate on what we did there and how we've expanded in just the last few months. Okay, I hope nobody was filming that. Okay. Just give me 2 seconds here. Yes, I suck. You can blame me later. Okay. What's that? All right. Has anybody got a really big hammer? Okay, I'm burning up time here. Akari, how you doing? You wanna give it a shot? Okay, we're gonna like sort of bounce to the end here. One of the things we developed for ShmooCon was in cow patty. There's always the ability to just take the WPA PSK key exchange hash, run it against a dictionary, and just see if we have that. Okay, I'm really sucking up here. I do have to apologize. All right. So basically what we did was cow patty, previously you had to feed it the four-way handshake, feed it a dictionary, and the computer would sit there just cranking away at hashing out all those dictionary words, and if it eventually found the same hash as what you had captured, you'd know the key. Well, there's this whole time-space memory trade-off that a lot of groups are now using. It allows you to just do all this work once to get the information hashed out and into a table, and then every time you calculate from that SSID, you're good to go. So, okay. All right. Come on. Come on. Yay! You're still alive. Okay. So unfortunately, Dutch couldn't be here. He was one of the other members that we were hoping to be here. Is anybody else on the Church of Wi-Fi site? Anybody around here? I know Mother is down here. Oh, there's a few others. All right. Okay. Okay, here's what we've been up to. The Church of Wi-Fi WPA lookup tables, 7 gigs of pre-hashed passwords for the top 1,000 SSIDs from Wiggle, now online as a torrent. And if you talk to Thorn afterwards, we've got it on a removable hard drive. You can suck it off to your laptop if you like. Basically, the demo that we did at ShmooCon had my laptop doing running cow patty, normally doing 12 keys a second. You do a pre-hash of all that information on a much faster computer. You bring it back, and now we were doing it somewhere in the order of 18,000 keys a second. So 3-order magnitude increase. So these are really useful things. The Evil Bastard was another thing that we released, which is a attempt at a man-in-the-middle modified WRT, which is a real favorite toy of ours. Unfortunately, Dutch was supposed to be here, and he was supposed to bring it, and we haven't found him yet. So if somebody knows where he is, please wake him up. We hopefully have the Evil Bastard around the rest of the weekend here, and we can give you a demo on that. Another update is Kiswin. How many of you have played with Kiswin? A couple back there. It's the Windows Sigwin port of the Kismet client. I've been maintaining this, and in all my talks with Dragorn and everybody who's involved in it, we're just depreciating this until new core comes out, because the only changes he's making at this point are just minor driver tweaks, not anything that affects it. So don't go looking for any new updates until that's. But I do have it on good authority from Dragorn that he's looking at a new, finally getting the client running within about the next month. So hopefully we'll have a new core release by the end of the summer. We've been busy. One of the things that came about on the NetStumbler and Church Wi-Fi forums has been the advent of the headless war driver. I know that there's been various efforts for car computers and everything to try to get just a simple computer. You plug it in, it fires up, starts scanning immediately. Well, Beekman was a really brilliant guy who came up with a way of doing this just on a modded WRT. We've also got some information about the Sneaky Bastard, which is a project I came up with. Also going to throw out a concept to you guys for a concept of a wireless virus based in hardware. Really curious to see where this goes. It's just, I think it's going to be the next vector for wireless attacks. Bigger, better, faster WPA cracking. I'm never happy. I always want bigger and better tables. This guy can attest to it. He saved my butt a few times. WPA, it's a good target, but kind of went for WPA too. It's a little more fun. All right. I'm kind of rushing here, but headless war driving. Everybody's got their laptop sitting in the front seat when they're out war driving. They got their rigs. They got the antenna on the roof and everything. I want us to see something. I've always had this dream of something you could just give to your grandmother. Say, here, plug this into the 12-volt cigarette lighter. Away it goes. You know, give me the thing back, and all of your information's on the card. What you need is GPS, storage, something to power it. It's surprising. I have not seen any before Beekman came around and started pioneering this project. There have been small embedded PCs and everything like this, but using a WRT, which is cheap, plentiful, you can get them anywhere. It just makes a nice, tight little package, and it fits beautifully on a dash. And a couple of guys, Beekman, King Ice Flash, Mother, Scrudge, they all stepped up. They all did their own variations on things. We've actually got a couple of them up here you can check out afterwards. Beekman has ported GPSD over to the MIPS processor on the WRT, so that was the major hard work. That's been done. That's going to be an iPackage available on his site if you just Google for it. I believe we're also going to have that on this church Wi-Fi site. I told him to upload that. I don't know if he has yet or not. All right. His first one, small GPS SD card, was an external GPS unit. Logs were saved to an SD card. He just basically pioneered everything. It's got rough iPackages, and he's also working on a backup power circuit so you don't lose connectivity or GPS lock when you're moving it between the vehicle and home and everything. This picture here. This is how it all started. Just a cheap eBay parts, a little soldering, nothing truly groundbreaking. It's just nobody ever seemed to have put it together before. You know, if I'm wrong, please prove it to me, but I don't know, I just think it's really cool. And you see the SD card up in the back corner by the power plug and the GPS hookup, right in between the WAN and link switch port 1. King Ice Flash, who was kind enough to send me his version so we could have it here on site, he has a temperature-controlled heat sink on this thing because his was always overheating. He wanted something, so he's got a nice little fan on the CPU, heat sinks, the whole 9 yards. This guy has a CO2 laser milling machine in his basement, the lucky bastard, and cut this absolutely beautiful hole in the case for the SD card mod. You can take off the outer case. You don't have to, wiggle everything out or anything like that. You can pop it open afterwards and you can take a look. It's really nice. Internal GPS, so as long as this thing's just sitting on a back package shelf for your vehicle or something, it's just good to go. It's quite literally what you could just give grandmother and say, here, plug this in, pop out the card and give it to me afterwards, and there'll be data. There's a picture of some of the internals here. That's the really nice hole that he cut. I can't tell you, I'm envious. Mother, who was kind enough to bring his unit, went even a step further, and all of the GPS, SD card, and even put in GPRS backhaul onto this thing, all on a custom circuit board that just plugs right in, and away it goes. You really need to start putting that out in a kit, because I want one. As you can see here, you don't see a lot of the wiring in that. It's all buried underneath, but etched his own board. I just love these things because this goes to show one person gets the idea, other people just grab it and run with it. This is the kind of development that needs to happen more and more. You get a really good idea, it works, just collaborate, share, because there's somebody else on the other side of the world that's probably got a better idea, or in a lot of cases I find they've already figured out the solution but are looking for the problem. Oh, there we go. Oh, jeez. Shot right to the end. Okay, I suck. Yeah, okay. I'm just going to switch over to the other laptop here, and you can see some of the data that we've pulled off of the one of these headless units. I think you can plug in here. Let's worry about it later. We're a little pressed for time here. There we go. So yeah, this is just the SD card that we yanked out of the King Ice Flashes unit. I had running about 10 minutes before the talk. And you see we've got full data. We don't have GPS because obviously we're indoors and we're not going to be getting signal. But it's just that easy. All your Kismet logs come out on the data card ready for submission to Wiggle. So, all right. Yeah, it worked. Okay, Sneaky Bastard was a project that I came up with when I had way too much time on my hands and way too much crap lying around. InventGeek.com has all sorts of interesting projects on there. They put an LCD panel on the side of a case and just other kind of make-like projects. They had a rogue server where a guy took a UPS and shoved a Linksys NSLU2 network hard drive NAS unit and an external hard drive into this case. The idea being so your evil MP3 collection, well, you can just stash this inside of a UPS case, and the feds will never find it when they're raiding you or something. I thought it was an interesting idea, but the whole idea of just storage just didn't make a lot of sense. However, if you have a rogue access point inside of this case, this is a much better platform, I think, than just for storage. A UPS is normally plugged straight into mains power into mains power, and a lot of UPSs have a network pass-through surge protection as well. So you've got power, you've got network. This is all we need if we want to have a rogue access point. Previously, for pen testing, I had used this guy. This is Edward. Edward has a Belkin access point built into him and matrix-style connections through the back of the neck. This was built because a friend of mine was always joking that when his daughter was born, I'd be handing his daughter a teddy bear with antennas sticking out of it and say, "Yeah, just go past the security men. Go past the security men." So just to shut him up, I actually built the thing. This is the little lady it was built for next to her, next to him. But this sort of thing is kind of hard to get past on a professional pen test or anything. You're not, a teddy bear kind of sticks out, but a UPS under your arm doesn't. So I had a flood in my basement a couple of years ago, and for some reason I kept the case off of an APC 350 UPS that got wet. Battery and circuitry was all fried, it was of no use, but I kept the thing for some reason. Gutted the interior, ripped out all the power circuitry, the battery case, the battery and everything. A little bit of soldering, jumpered around where the power control circuitry was. So now all of the power plugs on top still work. So you can plug this thing into the wall, plug in a lamp, everything works. Spliced in a power for the WRT's wall wart because I still wanted to be able to use the WRT for other things. Couple of patch cables run into the network surge suppression access, or the RJ45s on that, and you've got the perfect hidden access point. A UPS sitting under somebody's desk, plugged into the network, plugged into the power, isn't going to raise a lot of alarm bells. You load something like the Evil Bastard firmware or something like Feruza WRT, and who knows what kind of mayhem could occur with this thing. I mean, the imagination is your only limit. A few pictures here. From the outside, looks absolutely normal. Power button still works, everything. But on the inside, you've got, you can see on the right side, you've got the WRT spliced into a standard wall wart. It all fits. Come on, don't lock up on me. Okay, the picture's not that big. Okay, after the wireless contest, I think this thing's ending up in Lake Mead. There we go. No, I'm not making it a prize. Okay. Now this is when wireless hardware turns evil. This is something that was just rolling around inside of my brain ever since Cisco Gate last year. The idea being that if you own the hardware that everything's routing through, you own everything. You know, standard man in the middle stuff. However, there's all these questions that were running through my mind about, because Cisco Gate was about the high end, the enterprise stuff, you know, the most expensive stuff on the market, stuff I can't afford. But there's so many other devices out there now that are running various firmwares and everything. How do you know that the firmware you're running is the original one that was meant to be there? This question kept bugging me, and I kept investigating more and more, because so much consumer stuff, like these WRTs, like so many network switches and everything, are running proprietary or even open operating systems, but there's no verification method that what is actually on there and running is what is meant to be there, or what you put there. We didn't do a proof of concept on this one, mostly because it was just too dangerous and nothing really useful could come out with it. So I'm just trying to throw the idea out there and just see what happens. Other team for the wireless contest that I know is going to be competing is Preset Kill Limit. These guys whooped my butt last year, barely, and I am going to be winning the jacket this year. They have... Oh. I want to win fair and square. No, but these guys, at their job, have the unenvious duty of hunting down rogue access points on their network. And running around with the directional finding these things is always a pain in the ass. So what they did was they came up with the kill bot, which modded WRT once again. You hire a summer student, you plug this thing into the wall, it goes out in client mode, connects to any open access point it finds, tries to connect to an internal network address and PHP page, and then if it does, figures out which switch connection that connection is coming in on and just turns off that port on the switch. So the person that installed the rogue access point is trying to connect and do their thing, and it's like, oh, I can't get out anymore because, well, the switch is killed. Didn't you guys upgrade that thing to put them through a captive portal now? Big skull and crossbones on it? Yeah, you get a page that says you violated the acceptable use policy. So they always come in whining. It's like, why can't I get access? Why can't I get access? Well, here's the piece of paper you signed. Open source firmware is both a boon. It's both a good thing and a bad thing. It's a good thing because it keeps costs down, allows for additional development for fun tools like this. But any vulnerabilities, all the system internals, everything you need to know to do bad things is also available. On the WRTs, all the settings are maintained through the NVRAM. So if you reflash the unit, you're changing the software, but the NVRAM memory stays the same. This was a little fact that kind of scared me, because if you can reflash things and all your settings stay the same, the few little pieces of information that the average user sees and would be able to tell if something bad happened to their access point, they're still going to be there. So how do you know what engine is running under there is the one that's supposed to be there? There's no integrity checking for any of this stuff. Nobody seems to care that you have any idea of what's running on this router. You buy a Linksys access point at Best Buy or something like that. How do you know what is actually running on there is what is an honest-to-God Linksys firmware? You don't. You have to take it on faith. If it fires up, you see a Linksys page, it connects, it does everything it's supposed to, great. But how do you know? You don't know what's going on under the hood. This makes default access points a lot more dangerous. How do you run an antivirus on your router? Your router is a little computer now. you've got Linux on there, you've got open ports, you've got, it's doing full PC type things. How do you check this? Any vulnerabilities on the WAN side could lead these things to their death from remote flashing across the internet. You can see a virus that starts flashing routers across the world and making your own little, DOS botnet or something. You could even carry from that to infect the hosts inside the network, just anything. Snarfing passwords, you name it. To give you an idea, this is the situation that I envisioned. You get a WRT54G with an infected firmware. At 3 o'clock in the morning, WRT runs a cron job, looks for any nearby access points named Linksys, a known default. If it's open, it connects to it, tries to connect to the admin page. This is pretty much the same as what the killbot was doing. If it's already got a Linksys name, they probably haven't changed the default administrator password on the unit. And hey, if you can connect to that, you've got direct access to the flash utility. And you can actually flash these units over wireless. This is dumb. I don't know why they're like this out of the box. Unit gets reflashed, reboots. Because the NVRAM doesn't get changed, the SSID channel, all that stuff is maintained. And as far as the user sees, there was just a little blip at 3 o'clock in the morning. Still connects, still gets out to the internet, but you don't know what's being snarfed in the middle. So this is my really craptacular Visio drawings. Basically scans, connects, sends the new firmware. And then once that host gets infected, does the same thing. Connects to any other access points that are open, passes it along. In a campus type setting, this can be a real problem because, as anybody who's worked on a university knows, the amount of rogues that show up, the amount of students that bring in their default Linksys access points from home, they're everywhere. So, and they're usually right on top of each other. So one access point could see like 6 other Linksys networks and theoretically infect all of them. A few caveats to this idea. Default modes are assumed, but given the statistics that are out there, there's an awful lot of default access points. Could be a huge problem. And anybody who might be driving by and using those things, willy-nilly, like at a coffee shop or something, they could be hosts for something. Who knows? They could get infected, whatever. You could make rudimentary brute forcing of the admin page. Every day at 3 o'clock in the morning it connects, tries a certain chunk of key space, shuts down. Just only takes 10 minutes off. Login banners could trigger unit-specific attacks. So if an access point has a known vulnerability to bypass the admin page login, you could use that. You can also brick the router really easily if you're flashing over wireless. It's not a 100% thing, but having wireless routers just dropping off isn't a good thing anyways. You can just imagine the guys at Best Buy trying to figure that one out. Everybody bringing these things back saying, why is this thing not firing up? Well, you got a bad flash in there. It's like, well, I didn't do that. Just a lot of access points using open firmwares. So how do you verify what's running there? I keep coming back to this. How do you run an antivirus scan on your hardware side? We've all got it for our PCs and our networks, but we don't actually look at the stuff that is handling all that traffic. It's a computer. You could also do really evil things like the Linksys admin pages. Because it's an open source OS, it's right there in the source code from Linksys. Just take all those pages, copy, paste, done. Just turn on something small like Telnet in the firmware, and you get yourself backdoor access. Solutions I see, a checksum facility somehow of verifying what is running on there, make sure it matches to the known checksum for that version. However, that's really easily spoofed. I mean, if you're loading a rogue firmware on there, anybody can say, oh yeah, I'm this firmware number, here's my checksum, which is precisely what's on the Linksys page. kind of a not a good solution would be non-flashable hardware, but again, if there's other problems found, you wouldn't be able to upgrade legitimately. Proprietary firmware, I hate to say it, but sometimes not having access to all the source code can make things a little bit safer. Still means you have to audit everything and all that usual fun stuff, but you know, there's something to be said for it. Antivirus could do TCP profiling for changes. If the firmware gets rebuilt, there's a good chance that some of the flags and everything are going to get changed, and you'll see that, okay, it's gone from running a Linksys to OpenWRT or something. There's just so much hardware out there that, you know, switches, modems, routers, access points, they're all running this stuff, and nobody seems to be addressing what is running on them. Okay, this is the fun stuff. WPA PSK. I'm sure most of you are in here. You've probably heard of this. At ShmooCon, we added the Gen PMK utility to CowPatty 3, which allowed you to pre-compute large tables of keys so that future attacks on that SSID went significantly faster. So if you had a customer that had, you know, for the sake of argument, an SSID of Linksys, you could compute, you know, a billion-word table for a Linksys access point and be able to, in a very short period of time, test for a billion words before you actually started brute forcing. It's a time-space trade-off. If you're doing a lot of these, like if you're verifying installations, this can be a real help. Like I said earlier, we went from 12 keys a second on my laptop here to 18,000 keys applying a pre-computed table. So it's a big speed increase. The lookup tables that are currently available is the top 1,000 SSIDs with 172,000 word dictionary, came out to about 7 gig. Audit and Converge, I have to thank them because they're hosting the torrents and putting up with a lot of grief trying to keep them up. At ShmooCon, we were trying to release them. Things fell through. I want this stuff out there. We need seeds. Please seed this stuff. And OS X can also run CowPatty as well. And there's also built-in utilities for the for pre-computing keys within OS X. I just got the 10-minute flash there. 7 gigs is a good start, but you know, I wanted more. I wanted to be able to walk up to pretty much any network and take a whack at this thing and have a good chance of getting a password. Two guys, Skynet OS and GB3, they wrangled up 14 high-power CPUs for, you know, testing purposes in their office, most of which was my data. Kevin Mitnick, of all people, put me in contact with Mark Burnett, who wrote a really nice book called Perfect Passwords. Yes, I am pimping this. But he collected somewhere in the range of 4 million passwords from porn sites and other places just through Google of actual used passwords. These are things that people actually have used. So we mixed his password list in with a bunch of regular dictionaries. You know, they computed this for 3 weeks, 3 blown fuses, and the damn tables didn't work. Previously, I had screwed up and accidentally sent in the password list with a control character at the end of every single line, which was computed into the hash and completely changed everything. So I did it again. So if somebody wants to write a patch for this version that we're releasing that checks if it's Unix or DOS text file input and corrects this, I will be very thankful. Oh, you already put it in?
Yeah, I got it.
Thank you. Thank you. Learning from my mistakes. However, Hikari was kind enough to step up, and his research was already going on, and I got in touch with him and said, hey, you're doing research into FPGAs and WPA cracking. I think we need to work on this. You want to get in? You want to get in on this?
Yeah.
Okay.
Should I just steal that one?
Can we get? Oh, I think it's up.
Oh, okay. Testing. Oh, cool. Okay, so yeah, I added in a bunch of FPGA support for CowPatty, and I don't know if you know what an FPGA is, but it's basically a chip that you can basically design a whole chip in software and then compile it and throw it onto this chip, and the chip will function basically like what sort of chip you want it to function like. So you can basically code a processor like whatever sort of processor you want, upload it, and it'll behave just like that. And in my case, I coded it so it basically just does PBKDF2 and SHA-1 and stuff really fast. And I just accelerated that portion. And so it's actually like the transistors are set so they actually compute all that stuff in the hardware. So it's a lot faster than on a PC. So anyway, the performance numbers I get on like a decent laptop, aka not Renderman's laptop, you can get about 70 keys per second. On one of my FPGA cards, that's actually wrong. I get about 450 per second, and I'll be demoing that in a minute.
Okay, you've done optimization since we last talked.
Oh, okay. Well, yeah, it's about 450 per second, and that's on a tiny little compact flash card. I've got 8 of them in this system. This will take up to 15. This is actually a bigger card. The compact flash cards are less than half the size of this, and they get about 450 per second. So anyway, let's see. Yeah, so that should actually be about 6,500 keys per second instead of 3,000 there. But yeah, I ran it through this system right here, and it only took about 48 hours, so it wasn't actually 3 days, it was 48 hours. And managed to do that in the time that it took him 3 weeks on 14 CPUs. So pretty big speed improvement. And yeah, basically generated 40 gigs worth of hash tables for the top 1,000 SSIDs, million word list. And oh, so we have a Thorn online. Cool. So yes, it helps you.
Hopefully will.
Oh, for the 40 gig one?
Yeah, we'll hopefully have that up. Just need to talk to a few people before that. But if you do start downloading this thing, please seed as long as we can. We don't have a lot of money for bandwidth or anything like this. So the more seeding you can do for the torrents, the happier we'll be.
Okay, so yeah, cool. You can start downloading these if you want. I don't think I brought a copy with me, but do you guys have a copy?
No.
No? Okay, so just download them. Yeah, so we released CalPatty 3.0, and we're releasing CalPatty 4.0 today, right? Yeah. Josh Wright, I think he took off yesterday, so he's not here, but he threw all that stuff together. And it turns out that WPA2 has the exact same authentication as WPA, and you're only attacking the authentication, so it's pretty much the exact same attack for both of them. So did he even have to modify anything to get it to work?
I think you just had to add support for the parsers for the packets. That's about it.
Oh, okay. So a couple lines of mods or whatever.
It was surprisingly simple, and yet nobody else really had a valid attack vector against WPA2 until this.
Yeah, so amazingly simple. I guess I'll switch over to a demo just so you can see CalPatty in action. Let's see if this works. There we go. Cool. What mouse?
Yeah, we don't have a monitor for this up here, so he's got to look behind him.
I don't know if you can read that. That's just a prompt thing. Oops. Here. So normally you can just run CalPatty, and those are the different options here. The typical usage is you just do like -f and then a dictionary file. So I've got this really tiny one here. Then you give it a pcap file. I think that's -r. There. And then you give it the SSID. And normally on your computer, it goes pretty slow. Right now, this is maybe doing like about 50 or 60 per second, possibly. And that's just running on the CPU here. So I'm just going to take this and tell it to run on FPGA 0. I don't know if you can see that, but basically -F0. And this is only running on one card, so it's doing about 450 per second right now, and it should go through and find it, hopefully.
And that's just one card.
Yeah, I'll demo all the cards if you want to see that. Yeah, so it just found the passphrase. 435 per second. You can also use GenPMK, which is the tool that he was talking about earlier. And the usage is pretty similar. You just give it a dictionary file. like a hash file. That's the output, the SSID. And yeah, so normally it's really slow. I'm just going to run on the FPGA, just so it's nice and quick. So it's basically doing the same thing, but it's actually saving out all the computed stuff to a file. And then we should be able to take that file and run it through CowPatty, and you can see how fast that is. So let's see, -D. And so this doesn't use the FPGA at all. You can run this on your computer as long as you download these hash files. And there we go. So it did it at about 70,000 per second, and it just found it just like that. And with these huge tables that we have, you know, it maybe only take you like less than a minute to scan through all of them and, you know, go through 1 million words. So it's pretty quick.
So it sure as heck beats sitting there on site waiting for like 5 hours for, you know, to go through a really short dictionary. Yeah, you can crank through 1 million words in, you know, a minute, get ahead of the game.
Yeah. So since I basically made it so you can just specify which FPGA you want to use, if you have like 8 FPGAs or 15 FPGAs or 1,000, I wanted to make it a lot easier for people to spawn all these sessions and do cracking really fast. So I just made a really tiny little Perl script that basically starts up screen and then creates a screen session for like every FPGA and starts up everything properly. So I'm just going to demo that real quick. So with this, all you do is give it a dictionary file. I'm actually going to put in the 1 million word one, just so you can kind of see it in action. And exact same PCAP file. There we go. So it found 8 cards in the system, and now it's starting up the screen session. So this is one of the instances here. And there's another one, another one. Oh, we are? OK. So it should find it, and there we go. So it just found it out of the 1 million word list, and it was doing basically 450 per second times 8, whatever that is.
We're getting told we're out of time here, so I'm just going to kind of zip to the end here.
OK.
All right. But since WPA1 and WPA2 share the same key hash, basically all of these tables now work for WPA2 as well. So we got 47 gigs worth of words pre-computed for you. Start downloading them. Enjoy. And I think that's about it. We're getting the big crossbones here, so we gotta get out of here. But thank you. And sorry for all the technical goofs.